Welcome to the Probability Weekly Work Help video part 2. And actually I've divided this video into 2 sections because there's a little bit more problems in the second section. So this is the first part. So you can watch this one. I mean, I've given you 2 and you should kind of think maybe 2 days to work on this the rest of this homework. So you can watch the first half Monday and do these problems, and then the second half on Tuesday. Which of these events are independent? Circle all that apply. Here is what you can figure out independent versus dependent. For independent events, come on. The probability of the second event is not impacted by the first event. In other words, the sample set hasn't changed. You have the exact same number of chances, exact same number of total outcomes, exact same number of favorable. So sample set has not changed. If that's the case, the events are independent. Dependent events, just waiting. There we go. Dependent events, the probability of the second event is affected by the first event. In other words, the sample set has changed. Total number of outcomes has changed. Maybe the total favorable outcomes has changed. The favorable outcomes has changed. So the sample set has changed. All right, and so that's the criteria you can use to determine independent and dependent events. All right, and for these 4, you are looking for which of the events are independent and circle all that apply. All right, so, and you can just circle the letter, all right, A, B, C, or D. That's all there is to this one. All right, moving on to question number 2. All right, in a certain basketball league, so when we're finding probability, right, just as a reminder before I even go any further, probability of more than one event multiply the probability of each event. Oops, we got too many L's in there, or too many I's or something. All right, so let's look at the first one. In certain basketball league, the probability that the Stingrays beat the Manatees is 28%, which you would use 0.28. The probability that the Stingrays beat the Electric Eels is 34%. What is the probability that they beat both teams? So this is the probability of manatees and the probability of electric eels given that they already beat the manatees. Now, if they are independent events, then the probability of electric eels will be the same as the probability of electric eels given that they beat the manatees. If they are dependent events, you would calculate the probability of electric eels given that they've already defeated the manatees. Now, think about it. Does beating one team have anything to do with beating another team? Just a little hint there. All right. A jar contains colored stones. There are 4 pink stones, 9 orange stones, and 5 green stones. Ryan picks one stone, records its color, and puts it back in the jar. Then, and I'm just going to underline an important phrase there. I wonder why I'm underlining it. Puts it back in the jar. Then he draws another stone. What's the probability of taking out an orange stone followed by a green stone? So notice this is 2 events again, right? Beating 2 teams is 2 events. Orange stone and then a green stone is 2 events. So anytime it's 2 events, it's multiplication. Right? So you want to find the probability for orange and means to multiply. This is a reminder. Given, orange, the probability of orange and green, given that you picked the orange, or Ryan picked the orange. Right? So now, if these are independent events, the probability of picking the green remains the same. It is not impacted at all by picking the orange. So the probability of green is the exact same probability as the probability of green given orange. If they are dependent events, you then calculate the probability of green given that he picked the orange. Right? So in other words, if the sample set changed, you would find the probability of green given that the sample set has changed. But hint, he puts the stone back in the jar. So hopefully that's giving you a huge clue. And if it's not, go take a look at your notes. Right? We put that in there, what kind of event it is if you put it back in the jar. Henry has 3 black shirts and 7 blue shirts in his wardrobe. 2 shirts are drawn without replacements. This is 2 events, multiplication. And notice it's without replacement. He's not putting it back. What's the probability that both of his shirts are black? So you're finding the probability of black. What happened to the word black? The probability of black and the probability of black given that he's already picked a black shirt. All right, so if they are independent events, but hint it was without replacement, then it would just be the probability of black times probability of black. But if they are dependent events, when you calculate the second probability, you have to calculate it given that he's already picked a black shirt. So if they're dependent, the total number of shirts are going to change. The number of black shirts are going to change. All right. So, and I'm not going to go through as much explanation on the rest of these, right, that are very similar to this. They're similar and they're not similar. But it's the probability of black and the probability of black given black. All right. So I won't explain what the given means on the rest of them. High school dropouts. According to the U.S. Census, 8.4% of high school dropouts are 16 to 17-year-olds. In addition, 6.2% of the high school dropouts are white 16 to 17-year-olds. What is the probability that a randomly selected dropout is white given that he or she is 17 years old? That word given means conditional probability. It meant conditional probability over here too, but if the events are independent, it's not going to the given's not going to change it. So just a hint, these are now dependent events because we are calculating it out given. This is the conditional probability. When you see the word given and the conditional probability formula, I keep wanting to put two I's in there. I don't know. I think I'm starting the L and I don't go far enough and then I just give up on that L. And you'll know it when you see the word given. Conditional probability formula. The probability of A given B, excuse me, the probability of A given B, let me write that nicer, is equal to the probability of A and B divided by the probability that this is the first event, has already occurred. Now you don't have to use the conditional probability formula back here when it's easy to change the sample set. When it's not easy to change the sample set, you would use the conditional probability formula. All right? And a little hint, I'm going to give you one other big hint between 2, 3, and 4. Only one of these are the events dependent. And you can change the sample set. Here, how would you change the sample set when you've got percentages, right? And you should change those percentages, by the way, to decimals. And if you use this formula, you will find the probability that a randomly selected student, randomly selected dropout is white, given that he or she is 16 or 17-year-old. So this particular probability, it was the probability of white given 16 to 17. All right. In a school, the probability that a given student takes environmental science and geography is 0.25. The probability that a student takes environmental science is 0.72. What is the probability that a student takes geography given that the student is taking environmental science? Given, our big word there, that means conditional probability. So you are finding the probability of geography given environmental science, that they are taking environmental science. A conditional probability, the sample set is changed, right? Because we're only considering the students that are taking environmental science, not the students that aren't taking environmental science. Right? And so this again is given means conditional probability. Anytime we change our sample set, it's going to be a conditional probability formula. Sometimes it's easy, like when you're picking marbles and you don't put one back, you can easily change the sample set. But when we cannot easily change the sample set, we use the conditional probability formula and it takes care of it for us. All right? And so exact same formula. So this is for 5 and 6. All right? Exact same formula. A bag contains 6 red marbles and 4 blue marbles. What's the probability you will draw 3 marbles in a row? If you replace the marbles each time, you do not replace the marbles each time. All right? Replace. Sample set doesn't change. Do not replace. Sample set changes. All right? And picking 3 marbles means 3 events. In both of these cases, multiply the probabilities together. They are not the same problem, even though you are picking the same marbles. In each case, you are picking 3 blue. but in B, you do not replace them. If you really have any trouble with these, draw a picture. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. On the second one, you can cross them off when you pick it and you don't put it back. Or just go find 6 red marbles, 6 red anything and 4 blue anything, right? And you can move it, literally move it out of the way. Or just draw a picture like I just did. The mathematics test results of 50 learners were examined, and the results were recorded in the two-way table. And it's all filled in, it even has the totals for you. All right, so if a learner is chosen at random from the group, determine the following. So I think 8.1 is pretty straightforward. The learner passed. All right, so it's just total passed over total. That one is pretty straightforward. Your favorable is passing, and all of these, your total is the total number of students. The learner is from class B and passed. The learner is from class A and failed. All right, so none of these are conditional probabilities. The first one is just the probability of passing. The second one is the probability of passed. Oh, excuse me. B, not that it makes any difference. B and passed. So in that case, all right, they have to, it's the intersection, because and will be the intersection. Where do those intersect? When you have a table. And learner is from class A and failed. Probability of A and failed. In all the cases, this are your total outcomes. The total number of students. Right? And write these as fraction and lowest terms. For all. An automotive manufacturer buys computer chips from a supplier. The supplier sends a shipment containing 5% defective chips. Each chip chosen from the shipment has a probability of 0.05 of being defective. If each automobile uses 12 chips selected independently, so what kind of events are these? What is the probability that all 12 chips in a car will work properly? All right, so if it says independently, does one chip have any bearing on the next chip? Right? So you have how many events? There are 12 events. You should have 12 probabilities. A calculator will be a really good thing here. Your answer will be in a decimal, just like the probabilities, unless you want to change it to a fraction. 12 events, 12 probabilities. When you have more than one event, you multiply probabilities. And that's the end of this video, right? So I only went through 9 problems. It shouldn't take you too long, especially with my helpful hints. And I'll record the next video for tomorrow when you can finish the rest of the homework assignment. All right, bye for now.